Hello everyone, welcome to Sangam Tutorials, SP Gubbi online classes for NCERT, Cbse 10th standard for mathematics and science. So, in the last session of mathematics, we had solved very important problems, numericals on the application of similarity criterion for a right angle triangle. So, in this session, we will be going with the very most important theorem, which is called as the areas of similar triangles. So it's a very important theorem which will be asked in your examination for 4 marks. This is very important and it's dead easy. It's very easy, right? So before entering into the theorem, I will be in 2 modules. I am going to present this theorem today. It's a very special method to present any particular theorems. So in this theorem, that is areas related to similar triangles, we have an enunciation or we have a statement. So you know what is a statement, that is you have learnt in your previous classes, in your 8th standard geometry you have learnt it, in your 9th standard geometry you have learnt it. So a statement or an enunciation in geometry is a truth. So the truth of the statement, including that, the statement will be having 2 parts in it. One is the first part, that is starting from if to then. That part of the statement is called as the hypothesis, and from then to end of the statement, that is called as conclusion. So that follows for every enunciation and every statement in geometry. Here we have an enunciation or a statement. Both are same. Enunciation, statement, both are same. So today in today's class I have an enunciation. This enunciation, what we are going to prove today, the truth we are going to prove that can be proved in 2 particular ways. In 2 different ways it can be proved. One is, you can prove any enunciation or statement in geometry by doing construction and measurement. We can do it by doing construction and measurement. Okay, how it is? Very simple. In a triangle, sum of all interior angles is 180 degrees. That's an enunciation. So by construction and measurement, how can I verify that? Very simple. Draw any triangle, measure all the 3 interior angles of a triangle by using the instrument called protractor. Measure it, take the sum of all the 3 angles, it will be equal to 180 degrees. See, this is, you verified the truth of the statement by doing actual construction and measurement. It's one of the way. What is the other way? The other way of proving a statement, or other way of proving a statement or enunciation is the logical method. So when we get into a logical method, we go with a series of steps. That is, the logical way of proving a statement or an enunciation is called a theorem. That's called a theorem. So in the theorem, the first part of the statement, you are going to take it as hypothesis. You read it. So you don't read the next part of the statement. Without reading the next part of the statement, just by taking up the hypothesis, you are going to draw the required diagram. You are going to give the names to the diagram. The description of that particular diagram in your theorem will be called as the data. And you will read the next part of the statement, that is conclusion. And reading the conclusion part of the statement, you are going to write what is to be proved. So after that, if you need any extra data, that is, if the data is what given in the statement is not sufficient, then you are going to alter the diagram by doing certain constructions which is required. So this is done when the data is insufficient. So after the construction required part, you go with the proof. The proof of the theorem is written by using axioms, postulates, results of previous theorems, results of riders and results of identities. So by using all these things, not all theorems, not all postulates, not all axioms, the required axioms, required postulates and required previous theorems, you are going to take it and you are going to, step by step, you are going to present the proof very logically, right? So this is how to prove a theorem. That is nothing but the logical method of proving an enunciation. So once again I repeat, any enunciation or statement in geometry can be proved in two ways. One is by doing construction and measurement, another method is by logical proof. So in the first method, you are going to read the statement, you are going to construct your own diagrams, measure it, and you get the proof of it. In the second method, you are not going to draw any diagrams, in the sense not for measurement, not measurement diagrams you are going to draw, just you are going to use axioms, postulates and enunciations which are required and results of previous theorems, and you prove it logically. So that becomes the second method, that is called the logical method. So in this class, regarding the areas of similar triangles, I am going to do both the methods. That is, I have a statement, we will do the activity first, we will go with the construction and measurement, we will come out with a generalization, and that generalization will be the statement of the theorem, and then we will prove the theorem logically. So this is the most important class. Really you are going to get a very good grip at the end of the session. No doubt, if this particular theorem is asked in your examination, you will score 4 marks out of 4, right? So let us go with the concept. So I have an enunciation, I won't reveal the enunciation here, just we will do an activity, and from the activity we will extract that enunciation, and then we will prove the same enunciation logically, right? So I have a triangle, let us take it as triangle ABC. I have another triangle, I will take it as triangle DEF. So your mind is telling that, sir, both are looking same shape but different sizes. So geometrical figures which are having the same shape but different sizes, usually we call them as, yes, similar triangles, right? So these two are similar triangles. So let us take this as 90 degrees here, let us take it as 90 degrees, let us take this as 40 degrees, and let us take this also as 40 degrees. So 90 plus 40 is 130. So after that, 180 minus 130 is 50 degrees. 180 minus 130, 30, okay, it is 50 degrees here. So similarly this will also be 50 degrees. So 50 plus 40 is 90, 90 plus 90 is 180. So here also 50 plus 40 is 90, 90 plus 90 is 180, right? So in triangle ABC and triangle DEF, angle A is equal to angle D, angle B is equal to angle C, so both are equal to 90 degrees, here both are equal to 40 degrees, and angle B is equal to angle E, not C, okay. So angle C is equal to angle F, so it is equal to 50 degrees. Now in both the triangles, 3 pairs of corresponding angles have become equal. So it's no need to show all the 3 pairs of corresponding angles are equal, just 2 are enough. Okay, I have done it, no problem, it's not a fault here. So therefore triangle ABC is okay, and triangle DEF are equiangular. They are equiangular, okay. So if 2 triangles are equiangular according to the AA criterion what we have learnt in the previous classes, so if 2 triangles are equiangular, they should be similar. So therefore triangle ABC is similar to triangle DEF. So this is according to AA criterion. Okay, right. So now we are in a position to speak about the corresponding sides of these 2 triangles, because unless we show that both the triangles are similar by using any criteria we don't have any rights to speak about their corresponding sides. That is, we cannot take the proportionality between the corresponding sides, right? So now let us assume, let me assume, so let AB is equal to 5 centimeters, let DE is equal to 2.5 centimeters, let BC is equal to 6 centimeters this length, and let EF is equal to 3 centimeters. Okay, So let AC is equal to 3.8 centimeters, this one. So this will be equal to about 2 ones are 2, 1 remains, 2 nines are 18. So 1.9 centimeters, right, approximate. So it is something like this. Some measurement I have taken, right. So now we will take the ratio between the corresponding sides. So we know how to identify the corresponding sides. So opposite to 40 degrees is AC, opposite to 40 degrees is DF. So AC by DF is equal to, that is 3.8 by 1.9, 8 by 1.9, 1.9, 1 times, 2 times. So AC by DF is 2, okay. Then opposite to 90 is BC, opposite to 90 here is EF. So BC by EF. So BC by EF is equal to, that is 6 by 3, 1 time, 2 times. So it is 2 centimeters, that is, sorry, the ratio is 2:1. And then opposite to 50 degrees is AB, opposite to 50 degrees is DE, AB by DE. So AB by DE is equal to, that is 5 by 2.5. 5 by 2.5, 2.5, 1 times, 2 times. So AB by DE is 2. So therefore AC by DF is equal to BC by EF is equal to AB by DE. DE is equal to 2 by 1, or it is 2:1, or just 2. Okay, you can take any of the 3, whichever it is required, right. So we have taken the ratio between the corresponding sides. So we see that the ratio between the corresponding sides in all the cases it is 2:1, 2:1 and 2:1. So therefore generally I have written this, right. Now I want the area of triangle ABC and also I want the area of triangle DEF. So without the height in a triangle we cannot find out the that is the area of a triangle here. So I will draw a perpendicular. I will draw a perpendicular here. I will call it as some P. I will draw a perpendicular here and I will call it as Q. So it is P and Q, right? So these are the two perpendiculars I have drawn. So therefore BC becomes the base and AB becomes the height. So in this case, in triangle DEF, EF becomes the base and DQ becomes the height. Okay. So I can take the area of triangle ABC now. So area of triangle ABC is equal to half into base. Base is 6 centimeters into for example, let AP be some 3.4 centimeters. 3.4 centimeters and DQ be 1.7 centimeters. Okay, so AP half into base into height, that is 6 centimeters into 3.4. So I will take the area of triangle DEF, right, is equal to half into EF into DQ, that is half into EF into DQ becomes, EF is 3 and DQ is 1.7. Okay, now I will take the ratio between the areas of these two similar triangles. I will take the ratio between the areas of these two similar triangles. First I have taken the ratio between the corresponding sides of the similar triangles. Now I am going to take the ratio between the areas of two similar triangles. So area of triangle ABC by, that is to area of triangle DEF I have to write. So A is to B can be written as A by B. So in that manner, in the form of fraction I am going to write it. So area of triangle DEF is equal to, so we will write the equivalent of area of triangle ABC, that is half into 6 into 3.4 by half into 3 into 1.7. So half and half cancels. So 3 1 times, it is 2 times, 1.7 1 times, 1.7 2 times, so 2 into 2 remains, so that is equal to 4. So now we have got two results here. One is the ratio between the corresponding sides, we have got ratio between corresponding sides, that is we have got it as 2, and the ratio between the similar triangles, areas of similar triangles, we have got it as 4. Now we will generalize this result and we will come to a conclusion. So if we observe this, that is for example AC by DF and area of triangle ABC and area of triangle DEF, that is ratio between corresponding sides and the ratio between the areas of similar triangles. When we compare the ratio of these two, I can write like this, that is area of triangle ABC by area of triangle DEF is equal to AC by DF whole square. That is, please concentrate here, area of triangle ABC by area of triangle DEF value is 4, which is equal to AC by DF value is 2. So 2 is nothing but 2 square, because AC by DF is 2. So AC by DF whole square will be 2 square. So 4 is equal to 2 square is 4. That is, area of triangle ABC by area of triangle DEF will be always equal to AC by DF whole square, or you can write equals BC by EF whole square. BC by EF whole square, that is BC by EF also we have got it as 2. So 2 square is again 4, which is equal to AB by DE also we have got it as 2. So 2 square is again 4. So therefore AB by DE whole square. So this is true, very much true. You please do one thing, do a construction regarding the measurements what I have given you here. Construct a triangle using the measurements, that is BC, AB and AC. Construct a perpendicular there, do it here, do what all the things I have done here. Please do it by yourself by using the instruments. So at last you will find out that area of triangle ABC by area of triangle DEF will be equal to AC by DF whole square, BC by EF whole square and AB by DE whole square. So therefore we can generalize this. What the result we have got here, we can generalize this as by a statement in geometry, that is the areas of similar triangles, that is the ratio between the areas of similar triangles is, or the ratio, the areas of similar triangles is proportional to, that is this is a ratio, this is also a ratio, so two ratios are equal, so then we say that they are in proportion. So areas of similar triangles is proportional to the squares of their corresponding sides, the squares of their corresponding sides. So this is the generalization, I can take it here, or if you want to learn in more depth, I can go with another type of conclusion here. So this was the triangle I had taken there. So this was a triangle ABC and this was the triangle DEF, right? So this is one of the way. This is another way of proving the same statement by using construction and measurement, right? The areas of similar triangles, that is area of this triangle and area of this triangle. If you take the ratio between the areas of these two similar triangles, you cannot take two triangles which are not similar and try to apply this. You cannot do it, right? This concept is applicable only to two triangles which are already similar. Please note this. So I will take the area of this triangle, I will take the area of this triangle, I will take the ratio between the areas of two triangles. Just now what I have done here, I have taken the ratio here. So I took the area of triangle ABC here, I took the area of triangle DEF here, and then I took the ratio between the areas of two similar triangles. Then what I did is, I selected one of the side. For example, if I select BC, then I build a square on BC. I will build a square on this, on the side BC. So if this is BC, we know that in a square all the four sides are equal. So this also becomes BC, this also becomes BC. So what is the area of this square? That is BC into BC, that is BC square. And for BC in triangle DEF, which is the corresponding side? The corresponding side is EF. So let us build a square on this. So this will be the square So EF, this will be EF, EF, this will be E here. So EF into EF will be EF square. So very simple. If you take the ratio between the areas of similar triangles, if you take the ratio between the areas of these two similar triangles, that is area of triangle ABC by area of triangle DEF will be equal to the ratio between the squares, ratio between the areas of these two squares which are built on any pair of the corresponding sides of similar triangles. I have built it on BC and EF. You can build it on AC and DF. You can build it on AB and DE. So if you build it on AC, it will look like this. If you build it on DF, it will look like this. So areas of similar triangles are proportional to squares on the corresponding squares. These are the squares. So this is a square, this is a square. Squares on corresponding sides. So you can also build a square over this, and you can build a square over this, right? So the areas of similar triangles, the ratio between the areas of similar triangles will always be proportional to the squares which are built on their corresponding sides. So when you take the ratio between this square and this square, the same ratio, for example, if you get it as 2:1, then the triangle areas, the areas of similar triangles, the ratio will also be 2:1. So if it is 2:1, this areas will also be 2:1. This areas will also be 2:1. This areas will also be 2:1. So this is what we come to a generalization here. So areas of similar triangles are always proportional to the squares on their corresponding sides. So this is the generalization. So we have come out with a very good, very fine enunciation of the statement from this construction and measurement. So this is the construction and measurement. Please do it as a homework. Please construct these two triangles and you yourself check it whether this is true or not. You can check it. Or if you do not like that method, please go with this method. Please check it. You can also get it again, right? You will come out with the same generalization once again, right? So this is how we can prove a particular statement by using construction and measurement, right? So now we will go with the logical proof of the statement in the form of a theorem. So this theorem, these things will not be asked in your examination. This is for your pure knowledge. This is for your basics. These are the fundamentals you have to learn. Scoring lot of marks in mathematics, it's of no use without knowledge. Get the knowledge, then you score, then that's learning real mathematics, right? So the generalization what we have got here is the areas of similar triangles are proportional to the squares on their corresponding sides. So using this we will prove the particular statement logically. So that this logical proof will be asked in an examination for 4 marks, right? Statement. Areas of similar triangles are proportional to squares on their corresponding sides, right? So this is the statement. So Areas of similar triangles are proportional to the squares on their corresponding sides. Very simple theorem, easily you can score 4 marks. So, areas of similar triangles he has mentioned there. So, therefore, in order to prove this logically, we need the diagrams. So, we need to draw two triangles which are already similar. So, this theorem is applicable to two triangles which are already similar, right? So, we will go with the diagram. So, let us take it as triangle ABC. Let us take this as triangle DEF. Okay, right. So, these two triangles are already similar. So, we will write the data. Triangle ABC is similar to triangle DEF. So, therefore, AB by DE is equal to AC by DF is equal to BC by EF. BC by EF, right? So, angle B is equal to angle E because they are corresponding angles. Angle A is equal to angle D because they are corresponding angles. Angle C is equal to angle F because they are corresponding angles. So, now let us see what is to be proved. So, we have to prove that area of triangle ABC by area of triangle DEF is equal to, you select any one pair of corresponding sides. You can select BC and EF. So, that becomes BC square by EF square. So, it is BC by EF whole square actually, as the square applies for numerator and denominator both. So, that becomes BC square by EF square, right. So, here we have to write one statement as we have selected BC and EF. So, BC and EF are corresponding sides. Just we will mention that because in prove that we have written that, we will mention them. You can also prove AB square by DE square. You can also prove AC square by DF square. It is left to you, right. So, we will go with a small construction as data is not sufficient. So, draw AL perpendicular to BC and DM perpendicular to EF. So, draw AL perpendicular to BC and DM perpendicular to EF. Okay. So, this is the construction. Why construction is done? Because in the proof we are going to take the areas of triangles. So, in order to take the area of a triangle, we need the base and the height. So, therefore, as height is not given in the data, so we are going to construct that height in the construction part, right. So, we will go with the proof. Very simple. We will take the LHS first and then we will move on. Area of triangle ABC by area of triangle DEF is equal to half into, in triangle ABC, half into base into height is the formula to find the area of a triangle. So, therefore, in triangle ABC we consider BC as the base, BC into AL as the height, into AL by half into area of triangle DEF. So, in order to find the area of triangle DEF, the formula is half into base into height. So, therefore, half is a constant, base is EF and DM is the height. So, EF into DM, right. So, half and half cancels. So, we will write the remaining thing. So, area of triangle ABC by area of triangle DEF is equal to BC into AL, or you can write BC by EF into AL by DM and take it as equation 1. Because you have to prove that BC square by EF square, that is area of triangle ABC by area of triangle DEF is BC square by EF square, but we have only BC by EF. We need another BC by EF here in place of AL by DM, so that BC into BC becomes BC square and EF into EF becomes EF square. So therefore we need BC by EF in place of AL by DM. So we have to prove that AL by DM, that is this one, AL by DM is equal to BC by EF. That's the process, next process. So if I prove that AL by DM is equal to BC by EF and then substitute in equation 1, then BC into BC by EF into EF becomes BC square by EF square. So that's the next target. Now, so in order to prove that AL by DM is equal to BC by EF, I am going to select these two triangles. I can select this and this also, no problem, but it's a procedure. Select these two triangles. So in triangle ABL and triangle DEM, in triangle ABL and triangle DEM, so in both the triangles, angle ALB is equal to angle DME. Angle ALB is equal to angle DME. So reason is 90 degrees, and you got this 90 degrees by construction. Okay, then angle ABL is equal to angle DEM. So these two angles are equal because we know that both the triangles are similar. If two triangles are similar, then they will be equiangular. So therefore angle ABL is equal to angle DEM. Angle ABL is equal to angle DEM. So it's according to data. So now, in these two triangles, two pairs of corresponding angles have become equal. So, in two triangles, if two pairs of corresponding angles are equal, so therefore triangle ABL and triangle DEM are equiangular. Equiangular. So therefore triangle ABL is similar to triangle DEM according to, very simple, AA criterion. So according to AA criterion, both the triangles have proved that they are similar. Now, so triangle ABL and triangle DEM, they have become similar. So therefore their corresponding sides will be equal according to the theorem. So therefore AL by DM, therefore AL by DM is equal to AB by DE and BL by EM. I can write all the three ratios, but not required. I will take AL by DM is equal to AB by DE is equal to AB by DE. So reason is corresponding sides are proportional. Corresponding sides are proportional, right? But, right. So this is the turning point of the theorem here. But, right, look at the data. AL by DM has become equal to AB by DE. That is, the ratio between AL and DM is equal to ratio between AB by DE. But AB by DE is also equal to BC by EF. But AB by DE is equal to BC by EF. But AB by DE is equal to BC by EF. So this is according to data. So now, instead of, now we can see AL by DM is equal to AB by DE, but AB by DE is equal to BC by EF. So therefore, two things, that is BC by EF and AL by DM, two things are equal to the same thing. So according to axiom 1, if two things are equal to the same thing, they should be equal to one another. So therefore AL by DM is equal to BC by EF. Take it as equation 2. Now look at equation 1 and look at equation 2. So here, in place of AL by DM, I can substitute BC by EF. So substituting equation 2 in equation 1, area of triangle ABC by area of triangle DEF is equal to BC by EF, I have already here, BC by EF into Instead of AL by DM, I am going to write BC by EF. That is BC by EF. So therefore, area of triangle ABC by area of triangle DEF is equal to BC into BC is BC square, EF into EF is EF square. Hence it is true. I hope you enjoyed the entire theorem. So this theorem will be in your examination for 4 marks. You have to practice this. So how to practice this theorem? That is very important here. How to practice? See, to prove that I have written area of triangle ABC by area of triangle DEF is equal to BC square by EF square. That is BC square by EF square I have taken. You can take AB square by DE square in place of this and AC square by DF square in place of this again. So the same theorem can be presented in 3 different methods, 3 different styles. So whichever style you want, you can present it in the examination. So don't stick on to the teacher, do a little bit of research, understand the things, go inside the concept, try to enjoy geometry. That too particularly triangles, right? So I hope you enjoyed the entire theorem. You will really enjoy some more riders on this. So please practice the theorem. So send me through WhatsApp the 3 styles of presentation of this theorem. That is, I have done BC square by EF square, this one. So you please do it. AB square by DE square here and AC square by DF square. So 3 styles, please send it to me through WhatsApp. Stay home, stay safe and keep learning. Thank you.